Talk baseball. Anybody seen the movie Moneyball? About a while ago. No, no. Okay. Anyway, it was a movie about the Oakland A's, one of Major League Baseball teams, and it was they made it about the Oakland A's because that season in 2022 they tied for the most wins with the New York Yankees. Yet, if you look at the payroll of all the teams, you can see that the Yankees, $126 million that they're paying their players. And the Oakland A's are all the way down here, 40 million. Yet they won the same number of games. Now neither won the World Series, but still, it was a pretty good story. So they made a movie into it. So what we're going to do with this is we're going to look at their payrolls, which is quantitative data, right? And you can see the whole list of payrolls there. And we're going to talk about how we can present and analyze it. So like categorical data, we presented it in two-way tables, and we were able to show it using bar graphs as well as calculations. So we're going to look at a few graphs for quantitative data, one that you already saw the first day that we did that hiring discrimination activity, and then a couple of others, before we get into specific measures for quantitative data. So really the rest of this unit is devoted to quantitative data. The only stuff we did on categorical was in the last lesson. So how can we present this? Because a lot of times tables, lists of numbers can get very overwhelming, okay? Because there's many situations where there's even more numbers that you're calculating. Okay, so we want to present it in some sort of graph. And the first graph, like I said, we talked about, is a dot plot, where there's a horizontal axis, doesn't have to start at 0. There's no vertical axis, because we're just counting the number of times values occur. So in this one, this example for payroll, you can see that we've taken all these numbers and put them on the dot plot, ranging all the way from 30-something to over 120 million. Okay, so these numbers are going here, and then it gives us a chance to analyze the data. So we can just look, we can see there were teams that had the same payrolls 4 times, 1, 2, 3, 4. Otherwise, it was pretty spread out. Where are the Oakland A's? They're in one of these dots. They're at 40. Where are the Yankees? They're way over here at the top. The Yankees are usually at the top. Whoa. How come I can't get my person? Oh yeah. Okay. Why does it keep doing that? There. Okay. So using this dot plot, we labeled where the Yankees were, we labeled where the A's were, and based on the player payrolls, who would you expect to win more games? Well, it's kind of obvious. The Yankees. Advantages and disadvantages of the dot plot. Well, the main advantage is that you can see individual data values. That being said, the main disadvantage would be that it's quite overwhelming if you have really large data sets. That being said, there are programs that you can do where it'll just automatically generate a dot plot for you, like we did with that hiring discrimination activity, but you still have to enter all the values. So it can be a little bit cumbersome that way. But it does show distribution nicely, and then we can analyze certain things nicely that we're going to do later on in this lesson. So that's a quick review of the dot plot. Stem plot. How do we do a stem plot? Well, what we do is we draw a vertical segment that's going to separate the units digit of each data value from the rest of the place values. So for example, if you look, if we say, okay, the lowest one, and we usually go lowest to highest, the lowest payroll is 34 million. So what we're going to do to write 34, we're going to put the units digit on the right and the tens, because there's only a tens digit, on the left. This we call the stem, this we call the leaves. A lot of times stem plot is called stem and leaf plot. Then to enter the next data value, which is still in the 30s, it's 39 million. So we wouldn't go 39 down here because we've already got the 30s represented. We put 39 there. So that's showing two data values, 34 and 39. And then we would continue on with the rest of the payrolls, or the rest of the numbers. So for 40 million, there's two. So I start with 4 for 40 for the tens place. There's two 40 millions. There's 141 million. There's two 42 millions. There's a 45 million and a 47 million. And then we continue the pattern. We go into the fives. In the fives, there's a 50, a 55, two 57s, and a 58. In the sixes, there's a 60. Notice I'm going in ascending order, 62 and 63. In the 70s, 75, 76, 77, 78, 79. In the 80s, there's just one 80 million. In the 90s, there's 93, 95, and 95. The 100 millions, notice I got to put 10 now. And another space. So there's 103 million, 106 million, 108 million. Now for the 110 millions, there's none in the data. It goes from the 100 millions to the 120 millions, but we still have to represent the 110 million. So you have to put 11. We're just not going to put anything. And then finally 12. $126 million. Okay. What you need to add to every stem plot is a key. where you have to take one of the data values and show what it represents. And you can pick any one. So I'm going to pick the very first one. So I'm just going to go key 3 bar 4 represents 34 million. Dollars. So just again, notice on the right side, we just put the units digits, all data values. Okay. Or it could be if the data values are decimals, we may have to put tenths if that's the last unit in the data values, or hundredths if that's the last one. Okay. We'll see a couple with decimals too. So really what it is, it's kind of a dot plot that's turned on its side. So if you want to analyze it, a stem plot, what you do is you kind of tilt your head 90 degrees and you can see the way that it's distributed. So when I look at it like this, I can see that I've got a bit of a right skew going on because it's tailing off to the right. Advantages and disadvantages of dot plots, same thing as with, with stem plots, same thing as with dot plots. Okay. We see individual data values. But if there's too many data values, it can get quite overwhelming. Too many data values. In many ways, a stem plot could be better than a dot plot because if you look at these two examples, it's kind of hard to tell the shape of the distribution in the dot plot because there's so many individual ones. There's not many of the same. But when we put them in a stem plot and we group them by tens, we can see a little bit more of shape to it. All right, so what happens? Obviously, the big disadvantage of both of those is if there's too many data values, it can be very difficult to create. So we need something to create if there are too many data values. And that's where something called a histogram comes in. Don't confuse a histogram with a dot plot. They're going to look the same. But histograms, the bars are right beside each other, whereas bar graphs, they're separated. Histograms use quantitative data, bar graphs use categorical data. So if we've got a whole bunch of data values, what we want to do is put them into groups, intervals. So for the baseball payrolls, I decided I'm going to put them in intervals of 20. So from 20 to 39 million, from 40 to 59, etc., all the way up to 120 to 139. The number of intervals in the histogram should be around 5 to 8. Okay, to get a decent histogram. So there's two ways that we could count the payrolls, either by frequency, how often they occur, or relative frequency, which is percentage. Okay. All right, here's how we do it. First of all, I'm going to do the accounts. So how many were from 20 to 39? There were 2. How many from 40 to 59? If you look at that table on the first page, there were 12. Okay. From 60 to 79, there was 8. From 80 to 99, there were 4. 110 to 119, there was 3. And 120 to 139, there was 1. Okay. Sometimes the payroll, the split won't look like this. It'll look like 20 to 40, 40 to 60, 60 to 80, etc. Well, what do we do if we get one, like if this was 20 to 40, and this was 40 to 60, where do I put 40? You put 40 in the larger interval. Okay? So remember that, because if you split up your intervals like we did, like I said, if there's one right on the split between 2 intervals, put it in the higher. This one I made it easy because 20 to 39 and then separated it from 40. But I could have easily just, like if you did 20 to 40, 40 to 60, etc., that's still correct. You can do it that way. If we found the percentages, so 2 out of 30, 12 out of 30, 8 out of 30, etc., we'd get 6.7%. Here we get 40.0%. Here we get 26.7%. Here we get 13.3%. Here is 10.0%. And here is 3.3%. So let's do the actual histogram. First of all, I want to title it like I title a bar graph. So I'm just going to put 2002 MLB, which stands for Major League Baseball payrolls. And then I'm going to have a vertical and horizontal axis. The vertical has to start at 0, the horizontal does not. Okay, just remember when we do graphs like this. Okay.
Which percentage of the year calculated? You took those by
2 divided 30 times 100. Yeah. So here we're going to have the payrolls. Yeah, so payrolls, right? Separated into the intervals. So I'm just going to do it like this: 20, 40, 60, 80, 100, 120, 140. So I'm going to put those numbers in. For the vertical axis, well, I've got 2 things. I could do the frequency of it. I could do the counts. Or I could do the percentages. So I'm going to do the percentages. So I'm going to do the percent. So I'm just going to go 10, 20, 30, 40, 50, 60, 70, 80, 100%. And I'm not going to label every one. I'm going to label every second. And now we put in the percentages. So for 20 to 40, we're going to make a bar. And it's going to be 6.7%. So it's going to be pretty low. For the next bar, it's going to go right to the first bar up to 40%. For the next bar,
26.7, so a little more than halfway between these two notches. Somewhere around.
I should go a little higher.
13.3, somewhere around there. 10 goes in line with the first notch. 3.3 goes way down.
Almost non-existent. I'm quite even sure why I left this question in here because I gave you the answer. Like what would change if you made a relative frequency? Well, it'd be percent. So it'd be percent, the frequency percent on the vertical axis instead of frequency. And the advantages and disadvantages is really the reverse of the two previous graphs. The main advantage is that it's good for large data sets because you're breaking it into intervals. But the bad is you can't see individual values. Individual data values. So like if I look at the second bar, I know that 40% of them are between 40 and 60, but for all I know, all of those could be around 40. Maybe they're around 50. Maybe they're spread out. I don't know. I can't see the individual data values. But you can see here too that given the shape of the graph, we can see whether it's skewed right or skewed left or roughly symmetrical. We can find measures of center. Okay, we can find variability or how spread out the data values are, and we can see if there's any outliers. Yeah.
Does the Instagram only set in like groups of 20?
No, I would suggest that you break it down, try and keep it simple, groups of 5, 10, 20, depending on the data values. That's what I would suggest. I mean, you can choose any interval you want, but like if you choose an interval of 7, that can get a little tricky. Okay? So I would stick to nice clean numbers like 5, 10, 15, 20, etc. So all these graphs, but we're going to focus on the histogram, we can analyze the distributions. And we've already seen the 4 components of analyzing a quantitative distribution for a graph. So if you were asked to describe the distribution of the histogram, or in other words, describe the distribution of payroll amounts among Major League Baseball teams. So, remember the shape is either going to have a bigger left skew. It's going to be roughly symmetric. Modes just mean how many peaks there are. Unimodal means that there's one peak, and you look at the graph. Okay. This, for example, would be bimodal, 2 peaks. So often you will see that added when you describe the shape of the distribution. You'll say, oh, it's skewed to the right with a single peak. Okay. We can gauge the center of the data. Ooh,
I'm gonna pick all these that was the Canadian one. The general sector.
Variability, or remember, when you see the word variability, think spread out. How spread out is the data?
Well, we talked about range, which would,
Right now, we'll use range because we haven't looked at the other two yet. We're going to look at the other two next time. And are there any outliers?
in other words, unusual points.
Remember, for skews, if it, whatever direction it tails, that's the direction of the skew.
So this tails to the right, so it's a right skew. This tails to the left, so it's a left skew.
Okay, so let's say that we were asked to describe the distribution of the histogram. So we're just going to look at the histogram and we're going to answer all 4 questions.
You can just call it multi-peak. Yeah, multiple peaks.
What's that? Multimodal, you could say.
So if I was to describe the histogram according to schema. So first thing I want to do is I want to change shape.
What's the skew, or is it roughly symmetric?
Right skew. Anything you want to add to that? Single peak. And we can even identify where the single peak is. Single peak,
If you looked at it, it would be
60 to 80 million.
center. We just focus on the median right now. We're the middle here. My mistake, 40 to 60.
Because I'm wrong. That's why.
Now the center. So you got to think of it this way. If you take a roughly symmetric or perfectly symmetric distribution, the center is going to be at the peak. If it's skewed, the center will go where the tail goes. So don't always assume that the center is at the peak bar. Because if you look at this histogram, I would say the center's between 60 and 80 because it's getting pulled to the right a little bit.
So I would say approximately 60 to 80 million. The variability
Right now, all we really talked about is the range, the lowest to the highest. We haven't talked about the other measures of variability yet. So we would just say ranges from the low bar of 20 to 39 million to the high bar of 120. Actually, I changed it, didn't I? I should say 20 to 40. Outlier, remember, it's got to be unusual. It's got to be really separated. There's nothing really separated. There's no space between the bars in the histogram. So outliers appear to be none. So what are we looking for when we've got an answer like this? We're looking for the phrase describe the distribution in the question. When you see or write a few sentences about the distribution of the data, that's when you do STIVO. Okay, you got to do all four components. Yeah.
Doesn't matter in the order we talk about it in, right?
No, it doesn't. I just remember that word. That's all. I mean, you can, yeah, you can change it if you want. Solve.
Maybe probably random.
This stuff? Okay, sure. Remember it like that.
There is
Just, you would say, there appears to be an outlier. Let's say that we had one team at 200 million. You would say there appears to be an outlier at 200 to 220 million. Yeah. So like I said, each of these teams, if we go back to the specific example that we've been working on with these graphs and describing the distributions of these graphs, you can see that this is just sort of closing out these numbers. You take the average payroll or the average amount spent on per win. For the Yankees, it's their payroll divided by their wins. That means every win was over $1.2 million. For the A's, every win was under $400,000. So you can see why it's kind of a special story that they made a movie. Finally, there may be time, well, there will be times, I shouldn't say that, we're given two distributions and asked to compare the two. Okay? What you want to use is comparative words when you compare the two. So you would say, you know, the shape of this distribution is skewed to the right, while this one is roughly symmetric. The center of this one is whatever number, which is greater than the center of this one, which is whatever number. The range is this, which is more spread out than the range of the other one, which is this. Okay? Those are the kind of words that you want to use when you're comparing two distributions, and we will see that. Okay? I'm not going to worry about the discussion. I'm just going to let you read that on your own if you are so interested.